Okay, so we're going to have a look at another question from electromagnetism. Here we're told to describe the differences and similarities between gravitational, electric and magnetic fields. You can get these questions in exams. These worded questions are very unusual to answer within the context of a physics curriculum. You sort of just need to list as many things as you can. Usually this is not going to be worth many marks, so just saying this one is similar to this one because of this reason, this one is different to this one because of this reason, these two are similar to this one for this reason, that sort of stuff is going to be sufficient. So first we can say that the gravitational fields are based on mass, whereas electric and magnetic are based on charge. So this is our first point. Gravitation is mass-based. Electric fields and magnetic fields are charge-based. Electric fields stationary or moving charge, magnetic fields only moving charge. But nevertheless, the fundamental driver of those fields is charge, whereas the fundamental driver of gravitation is mass. So this is one point we could make. Another point that we could make is gravitation and electric fields move objects. We shouldn't say move objects, we should say accelerate. Accelerate objects in the direction of the field. Whereas magnetic fields accelerate objects perpendicular to the field. So we have gravitation pulls objects generally down. If you're thinking of the surface of a planet, you drop a rock, it moves down. Electric fields, if you have a field oriented in a particular direction and you place a charge in it, the charge will either move down or it will move up. It will only move in the direction of that electric field, either up or down, assuming that the field is oriented so the field lines are up and down. The same is true for gravitation, but in general you can't go up in a gravitational field. The gravitational force is usually pulling you down, right? So it's just one direction, whereas the electric is both ways, but it's along a cardinal line, right? It's along one of the lines of the plane. So if you orient it up and down, it's just on the y-axis. Gravitation and electric just move things on the y-axis if the field is oriented that way. The magnetic field accelerates objects perpendicular to the field. So the objects don't actually move in the direction of the field. They move in a direction orthogonal to the field, right, at right angles, perpendicular to the field, which is a slightly unusual quirk of magnetic fields. So here we have two demonstrations of similarities between pairs, differences with the other. Some combination of comments like this is going to be a sufficient solution for this question.